Hey students, today we are doing paper 4 of May-June variant 3, 2024. Question number 4, we have done the previous 3 questions in our last video, so you can go watch it. Let's start with question number 4. Dinitrogen tetraoxide N2O4 decomposes into nitrogen dioxide and O2. The reaction is reversible. As you can see, this is a reaction N2O4, which is a colorless gas, and it becomes NO2, which is a brown gas. This is a reversible reaction. Figure shows a gas range containing a mixture of dinitrogen tetroxide and nitrogen dioxide. Because obviously it's a reversible reaction, so there will be a mixture of both of these gases present at the same time. The gas range is sealed, the mixture reaches equilibrium, and the color of the mixture of the gas is a pale brown. Because a colorless gas is also forming and the brown gas is also forming at the same time, so the color is pale brown. Now, the question is, describe a reversible reaction at equilibrium in terms of, like when the reaction is in equilibrium, then what happened to its rate of forward reaction and the rate of backward reaction. So the rate of forward reaction and the rate of backward reactions are equal in every reversible reaction if it is in equilibrium. So equilibrium word comes from equal, which means balance. So if a reaction is in equilibrium, so its rate of forward and backward reaction is equal, means the speed at which it is moving backward is equal to the speed with which it is moving forward. And what happens to the concentration of reactants and products? They are same, constant. It no longer changes. Because if the reactants are also forming, the products are also forming, and they are forming at the same rate, so it means that the reactants and products, the concentration will be equal and they no longer changes. Part B. The pressure of the mixture is increased, all other conditions stay the same. The mixture immediately turns darker brown before the position of equilibrium changes. Explain in terms of particles why the mixture immediately turns dark brown. So in this question, as we saw that dinitrogen tetraoxide, it's a colorless gas, and nitrogen dioxide is a brown gas. So the question is that the pressure of the mixture is increased. We are pressing this plunger and the pressure on the gases are increased. If the pressure is increased, the solution or the gases turn dark brown. Now, why is it so and what's the reason? The reason is that because we are increasing the pressure, so the particles come closer to each other, they react faster, and the brown gas is forming quicker. So, if we are increasing the pressure, there will be the same number of particles, but now this time they're in the smaller volume. Same number of particles in a smaller volume will react faster. Will react faster. And that is why the solution turns dark brown. The temperature of the mixture is increased. All other conditions stay the same. The mixture turns dark brown. State what can be deduced about the forward reaction from this information. Now, what it deduces about the forward reaction, what it tells about the forward reaction. So in this type of question, mostly we have to write that whether the forward reaction is exo or endo. So let's see that the temperature of the mixture is increased and the solution turns dark brown. So here we are increasing the temperature. We are increasing the temperature and the solution is turning dark brown. It means that the solution is moving forward at increasing the temperature. So when the temperature is increased, the system is moving forward and the brown gas is produced more and more. It means that the forward reaction is endothermic. So if the forward reaction is endothermic, when we increase the temperature, it will move towards the side where the temperature is less. So at endothermic side, the temperature will be less. So the forward reaction will be endothermic. RD, sulfur is converted to sulfuric acid by the series of reactions. Yes, this is known as contact process. When sulfuric acid is prepared, sulfur dioxide and oxygen react to form sulfur trioxide in a reversible reaction. This is the equation. Complete the table using the words increase, decrease, or no change. Now, when we add a catalyst, what will happen to the rate of the reaction and what will happen to the yield of sulfur trioxide? Means sulfur trioxide is forming at the forward direction. So we have to see that if we are doing certain changes, that whether the reaction is moving forward or backward. So when we add a catalyst, obviously the rate of reaction increases. And the catalyst has no effect on the position of equilibrium. When we increase the temperature, it will move towards the side with the fewer number of moles. And the fewer number of moles are on the reactant side. On the reactant side, we have two moles, and on the product side, we have total of 3 moles. So if we increase the pressure, the system will move towards the side where the number of moles are less. So it means the system will move forward and the yield of sulfur trioxide will increase. And when we increase the pressure, the rate also increases. Because the particles move closer together and they react faster, they collide more. Deduce the oxidation number of sulfur in sulfur and sulfur trioxide. Now, in this sulfur, as the sulfur is alone here, it is not combined with any other substance. So in that case, the oxidation number of a substance will be 0. And as for the sulfur trioxide, SO3, for oxygen, oxygen is always 2 minus because oxygen is present in group number 6. That means oxygen will gain 2 electrons and get 2 minus charge. So oxygen is always 2 minus. So 2 minus, there are 3 atoms of oxygen. Minus 2 multiplied by 3, it makes oxygen 6 minus and sulfur will be 6 plus. So here we'll write plus 6 or 6 plus. Barium sulfate is an insoluble salt and is made by precipitation. Name 2 aqueous solutions that produce a precipitate of barium sulfate when they are mixed. Barium sulfate is an insoluble salt. Okay, so we prepared an insoluble salt by the method of precipitation. And in precipitation reaction, we will take 2 soluble salts, a soluble salt and another soluble salt, and it makes one soluble and one insoluble. So it gives an insoluble salt. It's a solid. So for this one, we must take 2 aqueous solutions. One must contain barium and the other must contain sulfate. So the one which contains barium, we can write barium nitrate. And why we can write this? Because all nitrates are soluble. All nitrates are soluble. So we can easily write nitrate with any metal if this type of question is asked. With a metal, we can write nitrate. And with the anion, which is sulfate over here, with the anion, any anion, we can write sodium or potassium. Sodium sulfate or potassium sulfate. Because all sodium salts are soluble. So to make it easy, we can write sodium with the anion part and nitrate with a metal part. Describe how to produce a pure sample of barium sulfate from the mixture of aqueous solutions. So if we have a mixture of a soluble salt and an insoluble salt with a precipitate of barium sulfate, we can get it by doing filtration. So what we can do, first step, we'll filter it. Second step, we'll wash the residue with distilled water. With distilled water. Then after that, we can dry the precipitates in an open air. Write an ionic equation for the precipitation reaction which produces barium sulfate. Now, if we write the ionic equation, that in ionic equation, the ions are involved. The positive ions and the negative ions. So for barium sulfate, the positive ion is barium. The negative ion is sulfate. And they will combine to form barium sulfate. Okay, we have to include the state symbols also. All the ions are always aqueous. Ions are always aqueous. And barium sulfate, as it's a precipitate, so we'll write solid with it. Soluble salts are made from dilute acids. Name the dilute acid and one other substance that react together to make copper sulfate. So to make copper sulfate, sulfates are made from sulfuric acid. Sulfates are always formed from sulfuric acid. And as for the copper, we can use copper oxide, or we can also use copper hydroxide. We can also use copper carbonate in it. Copper carbonate. Nitrates decompose when they are heated. When hydrated copper nitrate is heated, oxygen gas is produced. Describe a test for oxygen. The test for oxygen is the glowing splint test. Glowing splint test. And the observation will be it relights. Complete the equation for the decomposition of hydrated copper nitrate. We need to balance this equation. And for the simplicity, the reactant equation, in the reactant, the crystals, the hydrated crystals are already balanced. So what we'll do, as we can see, the copper here is 2. So we'll write 2 here with copper oxide. As for the nitrogen, it's NO3 whole twice. So the nitrogen is obviously it's 2, already 2. And we have 2 molecules of these hydrated crystals. So 2 into 2, 4, which makes NO2 also 4. And as for the water, if we see that there are 3 molecules of H2O, so already the hydrogen atoms are 6. And as there are 2 molecules of these crystals, which makes 6 into 2, 12 water molecules. Here, the 2 molecules of H are already present. So we'll write 6 here, which makes it 12. So that's how we'll balance it. Next question. Hydrated zinc sulfate gives off water when it is heated. So this is a question in which we have been given the crystals. And when the crystals are heated, the water of crystallization evaporates. It evaporates and we get only salt. We are remain with the salt. The student does these steps to find out that how much water has been lost. Student took the crystals, weigh it, the student weighs the sample of crystals, then heats the sample. Then after heating, again student weighs the solid. Student repeats step 2 and 3 until the mass of the solid is constant, to make sure that all the water has been evaporated. So why student does step 4? To ensure that all the water is given out. Next, in an experiment, 0.571 gram of hydrated zinc sulfate is heated until the mass is constant. The mass of zinc sulfate that remains is 0.322. The molar mass of water and zinc sulfate are given. Determine the value of X using the following steps. Now, in this type of question, when you have been given the mass of the hydrated crystals, then we heat it so that the water will evaporate. Now, in this question, we have to find out that how many moles of water molecules are there in the crystal. So basically, we have to find the value of X. So to find the value of X, these are the steps which we'll do. First step is calculate the number of moles of zinc sulfate. To calculate the number of moles, we'll do mass over molar mass. The mass of zinc sulfate is 0.322 and the molar mass is 161, which gives us 0.002. Calculate the mass of water. We have the mass of crystals, which is 0.574. This is the mass of the crystals. And from this mass, this total mass will minus the mass of zinc sulfate, which is 0.322. When we minus the mass of zinc sulfate from the hydrated zinc sulfate, we'll get the answer of hydration, the water molecules, which is 0.252 grams. Once we have the mass of water, we can calculate the number of moles of water by the same formula. Moles is equal to mass divided by molar mass. The mass of water is 0.252 and the molar mass of water is 18, given in the question here. So we'll divide it by 18 and we get the number of moles of water 0.014. Now to find the value of X, we'll do the moles of water divided by moles of the salt zinc sulfate. So the moles of water here 0.014 and the moles of zinc sulfate is 0.002. We'll divide it and we get the answer 7. So that's how we calculate the water of crystallization for any salt, for any hydrated crystals. First, we'll find out the number of moles of the salt number of moles. Then we'll find out the number of moles of water. Then we'll do the moles of water divided by the moles of zinc sulfate. And we get the answer, which will always be in a whole number.